Hello everyone, welcome back to the channel. If you're interested in electronics, programming, robotics, or the Internet of Things IoT, you've probably heard the term embedded systems. But what exactly is an embedded system and how is it different from a normal computer? In today's video, I'll explain everything in a simple and beginner-friendly way. So, if you're ready, let's get started. Now let us understand, what does an embedded system mean? An embedded system is a computer system designed to perform a specific task or a limited set of tasks. Unlike a general-purpose computer, such as a laptop or desktop that can run many different applications, an embedded system is built for one dedicated purpose. In simple words, an embedded system is a combination of hardware and software designed to perform a specific function. Some common real-life examples where embedded systems used are washing machines, microwave ovens, smart TVs, air conditioners, etc. Many people simply point out the listed examples as embedded systems, but it is not correct. The appropriate way to say this is, these are the applications where embedded systems are used as an integral part. The embedded systems are often found as an internal component of larger products, which doesn't mean that they don't exist independently. They exist, but they are less common compared to those designed as subcomponents of larger systems. Now let's understand how embedded systems are different from general-purpose computers. A general-purpose computer, such as a desktop or laptop, is designed to perform a wide range of tasks. Users can install different applications and use it for activities like browsing the internet, gaming, programming, and document editing. An embedded system, on the other hand, is designed for a specific task and usually operates within a larger device. The key differences are, embedded systems are designed to perform a specific dedicated function, whereas general-purpose computers are designed to perform multiple functions and run different applications. Embedded systems use dedicated hardware and software that are optimized for a particular task, whereas general-purpose computers use flexible hardware and software that can support various tasks. Embedded systems are usually smaller and compact in size so they can be integrated into different devices, whereas general-purpose computers are larger and contain components designed for broader computing requirements. Embedded systems consume less power because they are optimized for specific operations, whereas general-purpose computers consume more power due to their high processing capabilities and multiple functionalities. Embedded systems usually have limited user interaction because they operate automatically within a device, whereas general-purpose computers provide extensive user interaction through various input and output devices. Now let's understand what components make up an embedded system. An embedded system consists of several important components that work together to perform a specific task. The major components include microcontroller or microprocessor, sensors, actuators, memory, power supply, embedded software or firmware. Now let's understand in detail about each component. The microcontroller or microprocessor acts as the brain of an embedded system. It processes the input data, executes the instructions stored in the program memory, and controls the overall operation of the system. A microcontroller contains a processor, memory, and input-output peripherals on a single chip, making it suitable for small and dedicated applications. A microprocessor is more powerful and is used in complex embedded systems that require higher processing capabilities. Examples: ARM Cortex processors, Arduino microcontrollers, and embedded processors used in automobiles. Sensors are input devices that collect information from the surrounding environment and convert physical parameters into electrical signals. They allow the embedded system to understand changes such as temperature, pressure, motion, light, humidity, etc. For example, a temperature sensor in an air conditioner measures room temperature and sends the data to the controller for processing. Actuators are output devices that convert electrical signals from the controller into physical actions. They allow the embedded system to interact with the real world by controlling devices such as motors, valves, relays, and displays. For example, a motor actuator in a washing machine controls the rotation of the drum. Memory is used to store the program instructions and data required for the operation of the embedded system. Embedded systems typically use different types of memory, such as ROM or flash memory, stores the firmware or program code. RAM temporarily stores data while the system is running. The power supply provides the required electrical energy for all components of the embedded system to operate. Depending on the application, embedded systems may use batteries, DC power sources, or regulated power supplies to ensure stable operation. The embedded software, also known as firmware, is the program that controls the hardware components of the system. It provides instructions to the microcontroller or the microprocessor about how to process inputs, make decisions, and generate outputs. Without firmware, the hardware components cannot perform their intended functions. Some of the areas where embedded systems are widely used are consumer electronics, automotive, healthcare, industrial automation, aerospace, and defense. To summarize, an embedded system is a specialized computer designed to perform a dedicated task. We explored its definition, real-world examples, differences from general-purpose computers, major hardware components, and its wide range of applications. Understanding embedded systems is the first step toward learning IoT, robotics, and many other exciting technologies. If you found this video helpful, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss future tutorials on embedded systems and electronics. Thanks for watching.